Hello, 6th graders. This is Chapter 10.4 and the end of Chapter 10, in which we will find the area of composite figures. We're going to learn to recognize how plane figures are made up of polygons, and then we'll solve problems involving the areas of composite figures. These are really fun visual logic problems. I think you're going to like them. Let's get started. Let's begin by examining a plane figure and seeing how it can be divided into other polygons. Let's begin with this trapezoid, PQRS. We can divide it in many different ways into many polygons. The first way we can divide it is to simply draw a line here and divide it into a rectangle and a triangle. We can also divide it into three triangles by first dividing it into a triangle and a rectangle, and then dividing that rectangle into two equal triangles. There are other ways we could divide this trapezoid as well, but these are the most basic and direct ways. We can then use this information to calculate the area. Practice dividing a plane figure on your own. First, divide it into two identical triangles and a rectangle. Then, figure out another way to divide it. Name the polygons as you go. Let's solve a problem involving a rectangle and a triangle that are both contained within a trapezoid. Trapezoid ABDE is made up of square ABCE and triangle ECD. The area of square ABCE is 64 square centimeters. The length of line CD is 11 centimeters. Using this information, find the area of triangle ECD and then the area of the trapezoid ABDE. Okay, so let's figure out how to break this down. Use the information we know to calculate what we don't know. First, the area of square ABCE is 64 centimeters squared. We know that because this is a square, each side length must be of identical length. So 64 centimeters squared is going to be equal to length squared, or length times length. Length squared equals 64. So the square root of each side, this goes way back in our 6th grade math book, doesn't it? So the square root of the length will equal 8, therefore length equals 8. All right, so now we know some more information. This is 8, this is 8, this is 8, and this is 8. Okay, next step. Now that we know that the length of line EC is 8, we can find the area of triangle ECD. The area is going to equal 1/2 of the base times the height, or 1/2 of 8 times 11, which equals 44 centimeters squared. So the area of triangle ECD is 44 centimeters squared. Now, to find the area of the entire trapezoid, we simply need to take the area of the square and add it to the area of the triangle. The area of the square was 64 centimeters squared. The area of the triangle was 44 centimeters squared. Therefore, the area of the trapezoid is 108 centimeters squared. Okay, folks, here's one to practice on your own. Trapezoid ABCD is made up of square ABCE and triangle ECD. The area of triangle ECD is 60 inches squared. The length of line CD is 12 inches. Use this information to calculate A, what is the height of triangle ECD, B, what is the area of square ABCE, and finally, C, what is the area of trapezoid ABDE. Press pause while you work. We have a new idea to test out when you come back. In our next example, we'll be solving a problem involving a parallelogram, a triangle, and a rectangle. Trapezoid PQTU is made up of parallelogram PQRV triangle VRS, and square VSTU. The area of the trapezoid PQSV is 99 square inches. Find the area of trapezoid PQTU. Okay, so there's a lot going on here. We have 3 different polygons. We have our trapezoid PQRV, we have our triangle RSV, and we have our square STUV. So the first thing we're going to do is use what we know to figure out what we don't know. What we know so far is that the area of this part of our overall trapezoid is 99 inches squared. So this trapezoid within the trapezoid, right here, has an area of 99 inches squared. All right, let's apply the formula for finding the area of a trapezoid to find line VS. We're looking for this height right here, okay? So the area for the trapezoid is 1/2 times height times b sub 1 plus b sub 2. Let's substitute what we know. 1/2 times the height times b sub 1, which is 8 inches, plus b sub 2, which we can figure out because this line length is also 8 inches. It's the same as the other side of the parallelogram. So we take 8 plus 6 to get 14. That's our b sub 2, and that's going to equal 99 inches squared. So let's just keep working through these PEMDAS steps. 1/2 times the height times 8 plus 14 gives us 22 equals 99 inches squared. 1/2 of 22 is 11 H's. That's 99 inches. So dividing each side by 11 to isolate H gives us 9 inches. So our height here is 9 inches. All right, now let's find the area of square STUV. So if the height is 9 inches and we know it's a square, then this length must also be 9 inches. So the area of our square is 9 times 9 equals 81 inches squared. Let's add that here. Now to find the overall area of our trapezoid, we simply need to take our 99-inch area of the trapezoid, the internal trapezoid of PQSV, and then add the area of our square. 99 plus 81 gives us 180 square inches. Here's a practice composite figure for you. Go slow, take it easy. You can figure this out even though it looks pretty tricky. So the area of this parallelogram, ABEF, is 84 meters squared. Now just be really careful. We're talking about this area right here. ABEF equals 84 meters squared. Using what you know there, we'll find the area of triangle BDE. Label it in blue for you. Find the area of triangle BDE. That's this one. And then find the area of trapezoid CDEF. And that will be this trapezoid right here. Okay? CDEF. All right. Good luck. You can figure it out. Give yourself the time to do it, okay? If you get stuck, don't worry. We will work it out together tomorrow. We will also do lots more practice on finding the area of composite figures. Remember to think of these as fun visual puzzles, and that helps me feel a little less frustrated if I feel like I'm getting stuck. All right, I'll see you tomorrow. Thanks for your hard work tonight. Bye-bye.